Now that you've seen how easy derivatives can be when we look at things like the constant rule and the power rule, as opposed to taking those long limits, I'm going to make it a little confusing again. We're going to look at what do I do if I have two functions that are being multiplied together. It is not as simple as taking the derivative of each function. Please make sure that you make note of that in your notes, because that is a common mistake that I see year after year. So instead, what we have to do when we have two functions multiplying is use the product rule. So your book gives you the product rule different from what I do it. So I'm going to show you the book's way, and then I'm going to explain the way I do it and show you how they're related. So let's say I'm trying to take the derivative of two functions being multiplied, f of x times g of x. So the derivative of f of x times g of x, according to your book, is going to be your f of x function times the derivative of your g of x function plus your g of x function times the derivative of your f of x function. So remember that prime, that apostrophe means derivative. Since it does not matter what order we add in, and it does not matter what order we multiply in, I think of it as the derivative of the first, so f prime of x, times the second, plus the derivative of the second times the first. The reason I do is because in your next video, we're going to learn something called the quotient rule for when we divide two functions, and we're going to use this same method or same order when we divide. So it makes it easier to memorize both formulas if they're a little bit more similar. But again, notice that I'm doing the same thing. I'm multiplying the first derivative by the second function. I'm just doing it first instead of second. I'm multiplying the second derivative by the first function. Again, I'm just doing it second instead of first. So that is why they are the same, even though I do it in a different order than the book. I'm also going to give you here the derivatives of some different trig functions. Make sure you have those written down. I will, once we learn the quotient rule, show you in class how or why they work. I do not memorize them. Instead, I just understand how to derive them. There's a lot to memorize in calculus, so to me, it's easier to understand how to derive them. So for now, I'd write down the list so you have a list to use. And then, like I said, after we learn the quotient rule, I will show you how to derive them, how to get them. But for now, we're going to look at some examples where we're using the product rule. So let's say, for example, I have this function here, 2 minus x, times this function here, x squared plus 3x. If I want to find the derivative of this function, the first thing I'm going to do is I'm going to kind of list what I need in order to use my formula. Well, my formula tells me I need the derivative of the first function, the second function, the derivative of the second function, and the first function. So my first function I see is 2 minus x, and the derivative of my first function is the 2 differentiates to be 0, minus x differentiates to be minus 1, using my power rule and my constant rule. My second function, g of x, is x squared plus 3x, and the derivative of my second function, using my power rule, is 2x plus 3. Well, now that I have everything I need, I'm going to plug it into my formula. So I'm going to take the derivative of the first times the second, and actually, I'm going to say y prime, my derivative of my function, equals the derivative of the first times the second, plus the derivative of the second times the first. And notice that I have to keep entire functions in parentheses. Now from here I can go ahead and clean up my derivative, and I get negative x squared minus 3x after distributing. And after using FOIL here, I'm going to get x minus 2x squared plus 6. And all I'm doing is foiling. I feel like at this point in your math career, I do not have to show you how I foiled. And then now I'm going to combine like terms, and I get a final answer of y prime, the derivative of my given function here, is equal to negative 3x squared minus 2x plus 6. And again, notice I was not able to just differentiate each piece. I was not able to just differentiate this and leave it as multiplication. I have to go through my product rule. Looking at some more examples of the product rule, I have 3 of them here. So here is number 1 of my following 3. So I notice that I'm multiplying a radical function, a cube root function, by this second function here. So I'm going to go ahead and again set it up. So my f of x, my first function. And I know that in order to use my power rule, I have to rewrite the cube root of x as x to the 1/3. And then the derivative of my first function is going to be 1/3 x to the negative 2/3. And my second function, g of x, is going to be, and same thing, I'm going to rewrite it, is going to be 2x minus x to the negative 1. And the derivative is then 2 plus, because the negative 1 comes down, so when this negative 1 comes down and multiplies by a negative, I get plus x to the negative 2 using my power rule. Now using my product rule, I can say the derivative of my given function is the derivative of the first times the second. So 1/3, and I'm going to say it's x to the 2/3 on the bottom. So I need to rewrite that a little bit better so I can tell it's on the bottom. So I get 1 over 3x to the 2/3. Go ahead and leave it negative if you want. Times the second function, 2x minus, I'm going to say 1 over x. I don't care if you leave it as x to the negative 1, plus the derivative of the second, 2 plus 1 over x squared, times the first function, x to the 1/3. So now from here, I'm going to go ahead and clean it up. So I distribute in here, and then I'm going to go ahead and distribute in here, and I'm going to get f prime of x equals 1 over 3x to the 2/3 times 2x is going to be 2x over 3x to the 2/3 minus 1 over 3x to the 5/3, because I can add the exponents of 2/3 and 1, plus distributing x to the 1/3 in, 2x to the 1/3 plus x to the 1/3 over x squared. I'm going to stop here so the video doesn't get too long, but please recognize that I could do a lot more algebra here. I could reduce my x's on both of these two terms. I could also get a common denominator for all of my fractions and put them together as one fraction. But like I said, for time reasons, I will stop here, because otherwise this could end up being a 20-minute video. So I'm going to move on to the next example. If I have g of x equals sine squared x. So my first initial reaction is, how am I supposed to use the product rule with this? Maybe I can just use the power rule. I cannot use the power rule because the power rule says my exponent has to be on my variable. This exponent is on my function. Remember from pre-calc that this means sine x times sine x. So I am going to use the product rule. And when I use my product rule, I'm going to say that my first function is sine x, and the derivative of my first function is cosine x, and my second function is also sine x, and the derivative of my second function is also cosine x. So then according to the product rule, the derivative of my overall function, my derivative of gx, so g prime of x, is the derivative of the first times the second, so cosine of x times sine of x, plus the derivative of the second times the first. I combine like terms and I get my derivative is 2 cosine of x sine of x. Since I have one cosine x sine of x, another cosine sine x, I can say I have two of them. Looking at my third and final example, maybe I only had 2 examples. I thought I had 3 examples. It's not moving over to a third one. So I guess I had only these 2. So since I only had these 2 examples, I'm going to show you the algebra that I could use to simplify this. You have seen all the calculus. If you don't want to watch, if you say, hey, I got a pretty good understanding on that algebra, go ahead and stop the video now. But I will walk through it mainly because on an AP Calc exam where they have multiple choice questions, oftentimes you'll see a multiple choice question with this in the answer form. Often other times you'll see it with its simplified form. So I do want to show you both. So I am going to go ahead and rewrite where I was at. So this is again an extension from that first example in my more examples. So I have f prime of x equals 2x over 3x to the 2/3 minus 1 over 3x to the 5/3 plus 2x to the 1/3 plus x to the 1/3 over x squared. Okay, so doing some algebra with this, first thing I'm going to notice is that, again, I can reduce these. So remember, we can always subtract. So x to the 1 is the same thing as x to the 3 over 3. So that gives me 3 over 3 minus 2/3 is 2/3 times x to the 1/3. I'm going to go ahead and leave this one. There isn't anything to reduce. Leave that one because there's not anything to reduce. On this one, remember 2 is the same thing as 6 over 3. So when I subtract, I'm going to be left with more x's on the bottom, and I'm going to get 1 over x to the 5/3. So looking at all my denominators, I realize that my least common denominator is going to be 3x to the 5/3. So I'm going to multiply this function here by x to the 5/3, top and bottom. The second term already has that common denominator. The next term, I'm going to multiply top and bottom by 3x to the 5 over 3. And my last function, I'm just going to multiply top and bottom by, or my last term, I'm going to multiply top and bottom by 3. That then gives me 2x to the 6/3, because I add my exponents. Well, 6 over 3 reduces to 2, and over 3x to the 5/3. Minus, nothing changes for my second term. My third term becomes 6x, again 5/3 plus 1/3 is 6/3, which is squared, over 3x to the 5/3, plus 3 over 3x to the 5/3. And now that they have the least common denominator, for my last step, I can say that my derivative in simplest form after using algebra is 8x squared plus 2 all over 3x to the 5/3. Okay, and that is your product rule.